Hi everyone, so let's do today's daily LeetCode challenge question. This is today's question, right? Yeah, okay. I'll set a 20 minutes timer, which is starting now. Okay, so take key of each character from left to right. Take key of each character from left to right. So this is the string. Then you are given a string S consisting of characters A, B, and C and a non-negative integer k. Each minute you may take either the leftmost character of S or the rightmost character of S. You may take either the leftmost. What does this mean? Each minute you may take either the leftmost character of S, leftmost, or the rightmost character of S. Okay. Return the minimum number of minutes needed for you to take at least k of each character, or return -1 if it is not possible to take key of each character. Okay, got it. So I need 2 of each character, right? So it means here I will have A, B, and C only. So it means I need to have 2A, 2B, and 2C, right? So how will I get this? Minimum number of minutes for you to take at least key of each character. So each minute I can only take either leftmost. I can take either from left or right. So there are 2 ways, right? There are 2 options. Either I can take from left or I can take from right. So suppose I take from left this time, then it will be A. But if I took from right, then it would have been C. So if I took from left again after this, then if I take from left again, then it would have been A. But if I take from right, it would be C. Because in this case I'm still only doing left. So in this case, if I pick from left, then it will be, so if I pick from right this time and then if I pick from left, then it will be A. But if I pick from right again, then it will be B, right? So this way I think this is the way. So I think this is a kind of this, what is this called? I forgot the name what this is called. Anyway, like what is this approach called? Something like, I forgot, but because I have not done LeetCode for such a long time, right? So I forgot what this approach is called. But anyway, so this is about finding all the possible different solutions and finding the best out of all. So since C, you can see that there will be so many branches, right? So this will also branch out, and this will also branch out. So since there will be so many branches, so I will just, so this is all the possible solutions, all the branches are possible solutions, and one of the branch will be my best solution. So for every branch, whenever I find, okay, so suppose for example I found B here, okay, and C here. So whenever for any branch count of A, B, and C reaches equal to k, then I will return, okay, and I will also return the total number of, so this way every node it will return the best out of these two children, you know. Yeah. How many note? So this will. Oh my god, I'm so sleepy. It is already 10:54 p.m. and I have not had my meal, my dinner yet. I always try to finish everything. I mean, do everything in time, but always something comes up, and I I always tend to start everything very late. Like right now, I'm starting my lit code at 10:40, after 10:30, which is not good. But like I'm confident that I will try to. I'm confident that I will start doing at least one lit code in the morning and another lit code during the afternoon. Okay, I will not push it until this last minute of my day. Okay, so what was I doing? Yeah, so I was trying to find the possible solutions. So this is the possible solution, and the possible solution, and the possible solution. Yeah, I think this is the way. And so what are the different what was I saying? What is the different? Are there any other ways? I mean, I think in this solution only there is a way to improve. Maybe if I reach here, then maybe, use some kind of gas or memoization, so that if I reach here, then if I if I'm already in this, suppose if I reach here, okay, and suppose if I'm already in this state before, then I will not have to divide again, right? Go left and right again. So that is my thing. So this one is approach, right? This is one approach, this going backward and doing everything again. So this is one solution. What are the other solutions? So can I do this other something some other way? I don't think so, because I need to find the minimum number of minutes, and to find the minimum number of minutes I need to look at all the possible ways to find the minimum, right? Otherwise, how will I know that which one is minimum just by going through it once or twice? So I need to traverse all the whole tree, go backward, and then find the minimum out of all the possible solutions. And what else? No, I cannot see any other solutions. I'm so sorry, guys. I'm very lazy right now. I do not even want to code. I'm very sleepy, so I'll just look at the solution directly. Recursion time limit will exceed. Sliding window. Shit. So this is a sliding window problem. Oh my god, I don't even want to look at the comments, because if I look at the comments, then everyone will comment that, oh, everyone will write very intelligent comments, and then I will feel very dumb. So who thought DP? Yeah, me. Not DP, but I don't know what this called. Some backward something. Backward. I forgot what this is called. Something back something. Yeah. It's good that other people also thought similar things. DP. This is bad. 2 to the power n. Yeah, this is the approach that I was saying, backtracking. So backtracking is also a solution, but looks like it will time limit exceeded. So actually, yeah, I was right. Backtracking is also one of the solution, but it will exceed the time limit, because obviously it will be, because we are branching every time, right? So it will be 2 to the power of n. So why 2 to the power n? Because the depth can go until n numbers, you know. So that is why. So suppose if this is the, if so this is what, this is to the power 1, right? And if I branch out again, then what is this, what, how many parts will be there? 1 2 3 4, right? 2 to the power 4. If I branch out again, then it will be 2 to the power 3, 8. So there are 8 parts now. 1 2 3 4 5 6 7 8. This is to the power 3. So total number of nodes will be based on height. Whatever is the height, it should be 2 to the power that height. Okay, so one, two, three, 4, 5, 6, 7, 8. And the height can go until n numbers, right? So if n is equal to, like, if there are like 15 characters, then it can go until 15 characters. So that is why it will be 2 to the power n. So binary decision at this position leads to 2 to the power n possible combinations in the worst case. Even though there are base cases that can terminate some recursive paths, in the worst case scenario, solution requires, yeah, that's what I was saying. It will lead to the power n possible combinations and to the power n possible paths, you know. So that is why this is too much time complexity. But what is sliding window? Like, how can we solve this using sliding window? I don't know. Instead of deciding whether to take or skip each individual character, we can use a sliding window approach to identify which characters we don't need to take to get to at least key of each character. First things first, we'll rule out cases where this is impossible by counting the total occurrences of each character in S. If any character occurs fewer than k times, then return -1. Now that the core idea of the solution is to identify the largest removable window in the string such that removing it leaves at least k occurrences of each character, A, B, and C. The number of minutes required to perform this task corresponds to the length of the string minus the size of the largest window. Really? What is the question? Take at least k of each character. Oh yeah, but this question, yeah, this is actually right, because I can only take characters either from the left or from right, right? So it means that I will need to remove something in the middle. Wow, actually this was something like before, like I think 2 days back, one daily lead challenge question, it was similar idea. you know. So there also I could only remove from left and right. So I was searching for the window to remove here. Wow, so the biggest takeaway here is don't just jump straight to the solution, just think about optimal solution more. I thought about, okay, after this solution I thought about, oh, okay, is there any other solution, but I did not think about it more. I think I just had a preconceived notion that there is no any solution, so even when I tried to think, I did not come up with this solution. But if I had really thought about it creatively, then I think I could have come up, because this was similar. And yeah, so for that I think just keeping my mind open, really open, and and doing more examples with open mind. So if I would have done more examples with open mind, then maybe something would have come up, maybe that idea would have come up. Because it is so, like, it is so straightforward, isn't it? I can only move from left or I can only move from right. So obviously there will be some window that needs to be removed here, right? So each minute you may, obviously there must be some window, yeah. I can only take either the leftmost or rightmost. There must be some window here. That is the answer. So yeah. Uh, so yeah, I should look at more examples and do it more, because just by looking at the question, because it is so verbose, sometimes we might not get intuition just by looking at the words. But once we really try to look at example and try to get hang of what it really means, then it should come to our intuition as well. Because just by looking at this, it, like, just by looking at words, it might sound so different, and yeah. So just coming up, so playing with examples is really important. Playing with more examples, creating more examples, and doing it more. uh, so identify the largest removable window in the string such that removing it still leaves at least k occurrences. Then the number of minutes required to perform this task corresponds to the length of the string minus the size of the largest such window. To achieve this, we iterate the string to locate the window using two pointers, left and right. The pointer right progressively expands the window by including characters one at a time into the correct window. Sometimes the pointer left is used to shrink the window whenever the current configuration violates the condition that at least key occurrences of each character must remain outside the window. As we increment right, we add the character at that position to the window and update the counts. As we increment right, we add the character at that position to the window and update the counts. As we increment right, we add the character at that position to the window. As we increment right, we add the character at the position to the window and update the counts. If adding this character results in too few occurrences of any character outside the window, so whether a valid window is identified, whether the counts of outside the window are at least k. After completing the iteration, the minimum number of minutes required is given by subtracting the size minus total length of the string. So this is the original string, and largest valid window to remove is ABC. So remaining string after approval is this one. So total length minus size of largest valid window is equal to minimum number of minutes needed. Okay. Yeah. Thank